So one of the first things we need to understand is we're going to have vector quantities and scalar quantities. Scalar means magnitude only. Magnitude is how much, it's just the quantity of it, the number with the label, of course, but it doesn't tell you anything about the direction. A vector is going to give you both the magnitude and the direction. So a scalar quantity would be the house is 2 kilometers away. But the vector quantity, it's going to have to tell you not only the 2 kilometers, but the direction as well. So we would say it's 2 kilometers to the west. When we're talking about displacement, it is going to be the shortest distance from where you started to where you ended, along with the direction. It is a straight line distance measurement from where you started to where you ended. Now, in this little graphic here, it's going to show you going from your friend's house to your house. You can take different routes, and they will have different distances that you travel. So that was a pretty long distance. Now, a red car is going to go from your house to your friend's house. It traveled a much shorter distance. But if you hopped on your bike and drove along the line that connects almost right at your house to your friend's house, that's really close to what the displacement would be. It's not exactly because it doesn't actually come right to your house, but the straight line distance from where you started to where you ended, that's going to be the displacement. In every example, the displacement was the same. Now, actually, even better stated would be the quantity of displacement is the same. The blue car was traveling southwest, the red car was traveling northeast, and the bike traveled northeast. So the directions weren't the same. The distance traveled by the blue car was 2 kilometers. It took kind of that windy path, a lot of turns, actually turned around and come back. So it had a pretty big distance. The red car, it only went about 1 kilometer because it took about as straight as you can get with the streets. And the bike had the shortest distance of all because it did travel a straight line distance and it had a distance of only 800 meters. So, what about the displacement? What do you think the displacement for the blue car, the red car, and the bicycle would be? They're going from the friend's house to your house or from your house to the friend's house. Total displacement for the blue car, 800 meters. To make it displacement, we would say southwest. The red car, 800 meters. To make it displacement, we would say northeast. And the bike, it was 800 meters and it traveled to the northeast. If you begin and end at the same place, or if your origin and your destination are the same, your total displacement is going to be 0. Example we have here is the Earth revolving around the sun. In 1.25 years, it travels a distance of 940 million kilometers, but the total displacement is going to be 0. Again, distance is a scalar measurement. It's measuring only magnitude, how much, the quantity. Displacement is a vector measurement. It is going to be measuring magnitude and direction. It does measure the shortest distance from where you started to where you ended, along with the direction.